Hi everyone, and welcome to this video on deploying the index redis.py template file from the bfabric web app template library. I'm Griffin White with GWC, and today we're going to be giving you a little bit of background into how this file is working, how to deploy with Redis, why Redis, and then ultimately how to deploy and use the template application for your own applications. Okay, so in the last video, we covered the deployment of index-large.py. This video will cover the deployment of index Redis, and this video assumes that you've already followed the deployment instructions from the previous video, which covered cloning the repository, setting up the bfabric py YAML file for bfabric py library, setting up your .env file, setting up a virtual environment, and installing dependencies. If you haven't done all of that, please check the last video for the installation instructions. Now, just a couple of notes before we begin. This library is under active development, and it's possible that there can be some small bugs. So we welcome any contributions in the form of bug reports from GitHub issues or pull requests. Feel free to, this is an open source framework, so please feel free to make your contributions directly on GitHub. And then the other thing is about bug reports. So all of these applications come with a built-in bug report mechanism, but it's worth noting that in order for the bug reports to function, you'll need to have the Unix command line utility mail installed wherever this app is running. We don't cover those instructions here. If you're running this on FGCZ infrastructure, this should already be set up and ready to send to any UZH email address, including the OTRS ticket system installed there. Now a quick note, so Redis is a in-memory data store with a wide range of utilities. Here we use it for queuing jobs using the Python library RQ. It's a commonly used library for distributing jobs across compute nodes, so distributed computing. And this video assumes that you already have Redis installed, already running on localhost. If that's not the case, Redis is a relatively straightforward library to install. We don't cover the installation instructions here, but the link is in the description of the video, and Redis should already be installed on any FGCZ infrastructure which you are using. So now I first want to give you a background into the app architecture. So you can see here we have the web server where in purple, where the actual web application is running. And this app requires two running Python components rather than just one. So rather than the previous situation, we just had the index large. Now we'll be running index Redis and a worker script or multiple worker scripts on a or multiple compute nodes or compute servers here in orange. So a job is submitted via the web application to Redis, and then any compute nodes which you configure with a Redis worker will grab this job depending on which queue it's been submitted to. And this entire process is documented and logged, of course, in bfabric with the corresponding entities, which we'll cover in a little bit. So if you remember in the last video, we parameterized this .env file with some variables that our application was reading in during deployment. So now I have updated a couple of these. You'll need to as well. If we check our env file, so just to give you an overview what we're looking at here. So now we're telling it where Redis is located. In this case, we're running everything on localhost. So we're running as a test deployment. We're running Redis on localhost, and we're running the web application on localhost. If you wanted to distribute this across a compute cluster, you would need to specify where Redis is running, where the queue is running. And the default Redis port. This is the config file path. It hasn't changed. We're still running on localhost. We're still running on port 8050. I've switched debug mode to true so that you can see how that's looking in Dash. These have not changed. The gstore remote path, this is going to be where files actually get copied to in gstore when we submit the job. The scratch path, this is used as intermediary file storage, which you'll see. And you'll need to specify a TRX login and an SSH key in order to authenticate with the FGCZ user TRX copy for copying files directly to gstore. So here you'll also need to specify the corresponding URL where your attachments that we're going to link to the underlying entity are going to be available from. Then you need to specify the service ID, which is corresponding to the charges which your app will generate. So every time you generate a charge in bFabric, the charge is generated for a service. And you'll need to pick a service, with ideally one which is enabled so you don't run into issues. You pick an enabled service and specify the ID here. And then anytime you run this application with charging invoked, then it will create a charge of this service ID. Okay, before we begin, I just want to show you a little bit about how this job submission is actually working in the background. So this is the submission function. You'll find it in index-redis.py. And it takes as input the different user interface components as well as the token. And basically what we do is we kind of simulate running a compute job in which you would be creating resources, attaching them to work units, charging a container for this job, and then as well creating attachment files in HTML which can be attached to the underlying entity. Here we just create some dummy attachment files. We specify them as byte strings. We specify the path that they will be found at. We create some resources, some dummy resources. And then we specify all of these arguments. We pass all of these arguments to this function run main job, which we discuss later on in another more detailed video on developing apps in the bFabric Web Apps paradigm. So ultimately, this is a wrapper for running arbitrary bash commands, which are specified here on arbitrary compute infrastructure. It's all wrapped in this function run main job so that it can be connected with various bFabric entities. Okay, now that you've seen a brief description of what's going on under the hood, we can fire up this application. So in the previous video, we already created the app in bFabric. We already registered it in bFabric to point at localhost 8050. So what I'm going to do now is I'm just going to run this application. Python 3 index-redis.py, and now you can see we're running in debug mode on localhost 8050. I will open another window in parallel where I'm going to invoke a worker. So this worker is actually what's going to be doing all of the work of running whatever compute jobs are fired off in these bash commands, which you saw, which are passed to this run main job function. Python 3 scripts worker. Okay, and now you can see we have a worker running on localhost, listening to light and heavy queues. And we can switch over to our browser window to invoke this. So let's refresh our run. We just have a random run here. We had previously bound this application to the run entity. That's why it is found under the applications window on the run page. We can invoke this application. Let's just create one resource. Let's definitely charge for this run so we can see how that works. I'm gonna charge project 2220, run it in the heavy queue this time, and just put some random text in the resources. Okay, I'll now click submit. And indeed, I am ready to see this, to fire off this job. And it says success. And now if I look over here, the actual application had passed over the work to Redis, whereby the worker was able to see, hey, this job needs to get done, and started processing all of this, all of the bash commands and attachments, etc. So now, okay, we can see everything is attached. We're just waiting for a final success notification that everything has been executed successfully, and then we'll go back to the browser to see what happened. The charge was created and all steps were completed successfully. All right, so if we go back to the browser, we can see just refresh this. You can see the work units here. We indeed have a link to a new work unit which has been created by this job we ran. This work unit has a resource attached. We can see in the queue that we have these, we can see we have several different queues, and this job was completed successfully from the heavy queue. And now if we go to the logs, we can additionally see what has actually happened here. So first we logged in, the token was validated, we saved these attachments successfully. Okay, all files saved successfully. Now we begin run main job. We run some dummy bash commands, echo random text. This was invoked successfully. And now we can create a work unit here. That's this entry. And ultimately, and then we create attachment links. We register the resources. We create a charge here. And you can see all of the different actions that are taken by this run main job function are logged directly in this bfabric job object. We also have access to the original job here. Now if we go back to bfabric, we can refresh the page and we see also these two attachment links have been attached. They're running on GStore. We have our hello world attachment as well as our hello world a second time attachment. Okay, so just to recap, to get this application running, you just need to follow the same instructions from the previous video. Specify the different pointers in your .env file to your private keys and your Scratch directories and the server you'd like to log into, where Redis is running. And then you need to start up the app and you need to start up a worker. And this is all you need to deploy a multi-compute node distributed computing web application on the bfabric web app paradigm. So with that, I would like to wish you a good day and hope you have fun deploying and playing with these application templates. Goodbye.